Again, thanks a lot for welcoming me. And first question I have to you, who has ever used Make? Okay, when I ask this question, I understand that I get older. For you, what is IT when you use Make?
Integration.
Exactly. So it's not making it, it's not making to IT like many people do these days, but actually it's integration test. So it's a common acronym which was used in Make for a long time. And today I'm actually speaking about integration testing, and I will be speaking about two frameworks that actually make it really simple and interesting for all the developers. So Testcontainers and WireMock. Who has ever used one of them? Okay, and who has used WireMock specifically? Okay, not so many people, so I hope that this presentation will be interesting to you. So just to make a quick introduction, so I joined WireMock in April to help with advocacy and developer relations efforts, but actually I've been using WireMock since 2014 or so in Jenkins and many other projects, because for us it was awesome solution for various integration testing of our services. If you have ever used Jenkins, you know that there are more than 2,000 plugins, a lot of services, a lot, when we talk about Kubernetes, a lot of additional tools you need to run, and integration testing of all this mess is quite interesting. Actually, I'm on the governance board of Jenkins. I'm core maintainer, so if so, just in case, sorry. What else I do? I do quite a lot of open source development. I switched more towards open source consulting and community building. I'm a CNCF ambassador and the Continuous Delivery Foundation ambassador and TOC member. So we are working on various kinds of open source standards and integrations. Today, I'm representing WireMock, and actually what we do, what is our bread, is building a SaaS solution and a platform for all kinds of mocking on the top of WireMock. Yeah, just a quick tip. Yeah, the on-premise solution is also coming soon. So if you're interested, talk to us. We have Uri Maus, the CEO of the company, in the room. Hi, Uri. So if you want to ask anything about WireMock Cloud, ask me or Uri, and I'm happy to chat. But really, it's a SaaS, and maybe I'll show just a few demos how it actually makes things easier. Okay, what we are talking about today. So I will speak briefly about API integration testing, how actually I classify approaches, and then we spend most of the time on Testcontainers and WireMock frameworks, and how to actually take the right tool, and how to choose what you want to use and how you want to use them together. My slides are already public, so you can use this link if you want to get slides. I believe I posted it on Twitter just before the presentation. If not, yeah, this is the slides, and I will definitely share them. Okay, just a quick disclaimer. We are not talking about WireMock versus Testcontainers today, or actually, I believe that these two tools are complementary to each other. They're quite powerful. And if you use them properly, you can deliver a lot of value and a lot of quality through integration testing in your pipelines. So please don't expect me to do much of comparisons today. Okay, so what is integration testing? Yeah, this doesn't happen without this meme, I guess. But yeah, really integration testing is something that allows you to verify that your companies do not just work well on their own, but also work well together. And actually, when we talk about enterprises, when we talk about big projects, it's much more complicated than it seems. Because you may have dozens of different components. For example, when I was working at Synopsys, we had something like 50 components, hardware ones, software ones, embedded from compilers to operating systems. And yeah, how to test it together? It's always a big challenge. And many teams get involved. There is a lot of various secret knowledge about particular environments. So, for example, yeah, you rarely know how hardware engineers test your software. Hardware engineers always say it works on our simulator. They apparently don't really test on hardware these days. And a lot of things yet to discover in integration testing. And this is why this area has been always super interesting to me. These days, if Yeah, I forgot one slide. So these days, of course, we talk about software most of the time. So a lot of modern product development, whether it's hardware, software, whether it's finance, whether it's maker software, etc. It's actually a lot of software these days. And in all the areas, we move towards cloud-native solutions, towards containers, towards best practices like DevOps, continuous delivery, and a lot of other things. So basically, what was just a common practice for software development 10 years ago now gets adopted in the whole industry. And yeah, I believe that software actually already ate the world. And I think that kind of summarizes what we see these days with this ChatGPT and many other things that just appear everywhere. So APIs is, of course, core for all kinds of software. And when we talk about integration testing, APIs, whether it's REST API, whether it's gRPC, WebSockets, or any other implementation, is a way how services talk to each other. So who does use any kind of APIs there? Okay, I'm so jealous. There are people who don't do that.
But desktop applications.
Oh, that's nice. Okay, but yeah, for the majority of users, APIs are actually essential for the well-being of your software. The stability of this API, the availability of this API, and services behind them are critical for our applications. And hence, for us, it's important to do integration testing. And when we talk about modern approaches, when we talk about shift left, actually our development happens long before you have a first solution implemented. It happens long before you have a prototype of your software. You usually have a lot of design, architecture work by the time. If you're lucky, it's open API specification. If you're not, it's a bunch of UML diagrams. But it's still something that happens in all the big companies. You need to design before you implement the things. And actually, for prototyping purposes, for testing purposes, when there is a lot of parallel development, there is a good case for doing actually verification and testing of components before your software even gets created. Historically, creating a client side is very important because if we talk about user experience, developer experience, you need to prototype the client side first, whether it's mobile application, whether it's web UI, because this is something where what you get value from. All the backend, while it's super important, is just an implementation of enabling you to deliver these features. And this is why it's important to do some integrations. There are standards, some implementations, prototyping, and this is important to actually do this integration testing at early stages. There are solutions for that. So, for example, OpenAPI or Swagger as all the specification. This is actually a way to define your API. There is again UML. There is a lot of different specifications, especially in automotive, hardware industry, and finance. There is actually a lot of specific standards that define how the software is implemented and how they should work. But in any case, you eventually end up doing API testing. And for me, there are 4 types of this API testing available. So, of course, you can do things in production staging. So basically, your developer hacks something, publishes it, and says, here's my container that implements the test environment, talk to it. Or this is our full production system. Nobody knows how it's constructed, but you can verify that. So it's testing again, it's production and staging. It's super accurate because in theory, it implements the real system. In practice, it's very slow. It's super difficult to maintain. And when we talk about modern development, it's actually too much luxury for us to wait until this environment is provisioned. So it's for acceptance testing, maybe, but definitely not for us doing the development and implementing things. On the other side of the spectrum, we can mock on the code level. So if you're a Java developer, there are frameworks like Mykita, PowerMock that basically allow you to isolate bunches of code, mock them, and implement the responses. It's good, actually. This is something we use heavily. Yes, with modern Java versions, it becomes more and more complicated because of reflection restrictions. But still, these solutions are really nice. The problem with them that they actually isolate all the interaction. So you cannot do really integration testing. You can just verify that your code in principle does something right. If all your protocol implementation, connection implementation, network layer, and the service outside does things right, which is not something happens often. So there are two approaches in the middle that I actually like and that we heavily used in day-to-day job. So it's testing against simplified implementation. So if you can take your big system and put it in 1 or 2 containers, basically for testing purposes, then you can use frameworks like Testcontainers. Or another approach, if you have API specification, then you can actually expose this API specification by something that you can test against. So this, for example, what WireMock does, it takes mocking definition, etc., and basically provides a mock service without any business logic under the hood. So you cannot test the server side, but you can test all the interactions if you have proper definition. So these are the two approaches, and they're actually super valuable for integration testing because, this is a kind of the subset of common software delivery pipeline. They usually something like 100 blocks or so, but we just take 3, doing unit tests and then integration tests. We always write a lot of unit tests because they're simple, they can be tested, they can be debugged. You don't have to wait 5 minutes or 5 hours before the test actually launches on your test environment. And this is why there is tendency to write everything as unit tests. And there is also tendency to shift left all kinds of integration testing because then you can actually make it fast. And frameworks like Testcontainers and WireMock allow doing it because if you can run an integration test and the environment can be provisioned in a few seconds and you can still debug your code, it's perfect. If the service runs in containers, so be it, but you can do all the verification and development on your side, which is the key point of and key added value of these frameworks for us. So when you develop, when you get to test interaction, actually now it's not more complicated than taking JUnit and writing a simple test rule. I will show just an example in a few seconds. So who has used Testcontainers before? Okay, quite a lot of people already. So this is one of the trending technologies. Testcontainers is a project started about 3 or 4 years ago, and 2 years ago, Atomic Jar, an enterprise behind Testcontainers, was formed. And as I said, the goal is actually to provide a simplified and containerized instance. Who does deliver products as container images already? Okay, not so many people. But in theory, if you already deliver in a container, then you can just put it container and provision in your test environment, pass some configurations, and then you can have something testing. Obviously, there can be really big containers. So last week we had a presentation by CERN, and they said that they have a container of a size of 80 gigabytes. Well, there are some anti-patterns, but in general, containers are supposed to be small and fast. And Testcontainers actually enables testing of these ready-to-fly images where they could be simplified. It provides container management layer that basically spins up container and shuts it down within your test, so it can be single shot. So just in one unit test, it can be on the class level, or it can be actually on the test suite level. So it actually allows to manage the instance flexibly. And it can also build the images on demand. So when we develop, when you need to customize something, you can actually build the image too. So this is just an example of how we use Testcontainers in WireMock. I will speak about it later. Is it visible enough? Okay, so it's JUnit 5. It's basically the same with pretty much every other unit testing framework on the earth. Whether you write in Java, whether you write in Python, it's more or less the same. Here we have annotation, Testcontainers, so it's basically it initializes Testcontainers framework. And then we just have WireMock container as a definition. And here, for example, we say that we use WireMock container version 2.35. It's the last stable release of WireMock. And we provide an official image for that. And then we just put additional mapping to emulate interface, which would be hello world endpoint. And basically, this is what we do. And then magic happens, because when you run the test, you just ask this field with the URL for /hello and write a request. That's it. So you don't care about how the service was provisioned, how it runs under the hood. So if you have everything generalized and in container, so this is how it goes. Simple, yes. And actually, while it's quite simple, it's very powerful too, because there is a lot of features under the hood that we don't see. So first of all, so test containers is a complex framework. It puts uses a lot of rules. It's not a rocket science on its own, because when Docker appeared, many projects, many companies started doing things like that for integration testing. So it was quite clear that Docker is powerful for integration testing. But what they actually did, they made it a commodity, make it simple to use. So we don't have to manage everything. The library manages it for us. And it is based on Docker engine. So currently there is only one engine that is supported by test containers. So there is a lot of discussions about supporting it on the Kubernetes level, but in principle, it works quite well. Moreover, it can use actually groups of containers. So it's called the Docker Compose, but what in principle it is, you can provision a set of containers that talk to each other. So for example, you have 3-level application. So you provision server side and the database as 2 containers connected to each other. And you still write your client like you would do in classic 3-tier application with Spring Boot or whatever. So you can actually provision multiple containers and multiple implementations. And then you just write your tests. You don't have to worry about anything. You can use very basic things like that, where so I believe, it's rest assured. So I just do a few verifications, but you connect it to your test framework and just verify all you need. And it's a real implementation. So whatever you have inside, it actually works. And one theory about using containers in your test environments, actually we see it with WireMock 2 quite a lot, that it's slow. Actually, it's not, because there is a lot of added value features which we do not see that are quite handy. So for example, test containers can cache the Docker images. It can suspend containers between tests. So for example, if you do not care about the state of container for particular test, you can just halt it and then provision in less than 1 second. And also there is quite a lot of termination inside, because for us, when we use frameworks like that, the key pain is actually runaway containers, runaway resources like networks, or names being acquired. So basically test containers takes care about all of that. And for us, it becomes very simple. What's important that there are actually implementations for a lot of existing technologies. So whether it's a database, whether it's a message broker, or whether it's WireMock, you have an opportunity to use them in the test container, and it's quite flexible. If you think that for every implementation you need to write your own test container from scratch, good news is that you don't. But if you want, there is of course implementations for that too. And it's not just Java, so many modern languages are supported. And who is open to use SaaS here? Okay, not so many people. But yes, if you don't like to use containers locally, Atomic Jar, they actually provide a SaaS offering. So why it's interesting is because I believe that SaaS is actually super powerful and it resolves a lot of issues for many companies. And we at WireMock also provide WireMock Cloud. But for your information, if you want to put test containers in the cloud, there is also a solution for that. So for big Docker Compose images, for larger scale setups, it actually makes sense. Because if you have a small test containers, it runs locally, but for bigger implementations, etc., uploading it to the cloud could work. And since the APIs are the same, it makes total sense in my opinion. Okay, WireMock. So now we go a bit deeper, but at the same time, we go higher on the abstraction level, because now we don't have test implementation at all. We just rely on mock definition, etc. And for that, there is a lot of frameworks. In Java world, the 2 most popular ones is WireMock and Mock Server. And for me, WireMock, I think that Yeah, I started using WireMock in 2014. I still believe that it's one of the most popular tools. I actually used it a lot in cloud-native environment. I know that there are frameworks like Microx, but I think that WireMock is still the most interesting thing. And for me, yeah, it's open. Sorry, I started losing microphone. So WireMock has been around for more than 10 years by now. It actually has something like 5 million downloads a month, and it gets widely used in open source ecosystem, in Java ecosystem specifically, but other implementations are also quite popular. For example, .NET, Python. So if you have multi-language environment, it's also something that you could probably consider. Key features that we have, it's not just simple mocking of APIs. So when you say I will show it later, but yeah, basically you say that there is a request and I want to have this response. So this is what most people perceive as mocking, and what many people think they can implement in 5 minutes. And yes, they can, but it's not what API mocking is. Because there is a lot of various things. For example, WireMock supports stateful behavior when it stores history on transactions and reactions. It can inject various faults and latencies. For example, if you need to do some stress testing, if you need to verify responses. It also has a lot of microscripting and dynamic response templating if you need to have advanced responses. And one of the important features is that it can actually record and playback. So if you have an old server, something legacy, you can plug WireMock as a proxy, record what happens in interactions, and then reproduce these interactions, reverse engineer them, and build quite stable tests. On the top of it, of course, WireMock has a lot of capabilities needed for Java development, including all the provisioning and rules as I presented before. So I'm not even presenting it again because it's just a simple library, and I will show later how it works. So for me, WireMock these days becomes a tool that actually can mock all the interfaces and all the implementations. So before that, we were using it just for Java, but now it actually becomes available for all the implementations, including standalone setups. So if you want to run WireMock as external server, there is WireMock Docker. There are Helm charts, there are test containers model, which I will briefly present. And there is a lot of adapters for different platforms. So regarding WireMock ecosystem, who is a Java developer here? Almost everyone. So I will just keep this slide. And this is what we have for Java. So for Java, we actually have the core implementation of WireMock is in Java. Currently, it supports Java 17, Java 21, pretty much works. So let's see what happens on the release candidate. But it's not just it. For example, if you use Kotlin, so the next talk will be about Kotlin, and we have a few quite good additions. So for example, DSL binder. So if you like writing Kotlin styles, or if you want to define coroutines, it's possible with adapters. So there is a special library for that. There is integration with modern frameworks like CodeTest for WireMock, and the same for other languages like Scala, Groovy, etc. Moreover, for technologies, we are also quite diverse. So it's not just JUnit 4 or 5, which is kind of low-level unit testing these days, but also there is, for example, Spring Boot implementation that actually can connect to Spring Boot definition and rebuild WireMock right from that and quickly connect to the instance. The same for Spring Cloud contracts. There is existing Quarkus extension if you need to embed WireMock in Quarkus. Same for Micronaut. There is a prototype on GitHub. If you like doing it old style, there is Maven and Gradle plugins, so you can basically run your test, and WireMock is actually provided on the build tool level for all the whole of your test instances. Whether you want to do it, I do not know, but you can. And also Spoke, Pact, and a lot of various implementations. So there is actually a Google Doc with WireMock ecosystem. Currently, I counted around 70 repositories covering different tools. But for me, there are two main parts. It's WireMock Java, which is integration test, and also it's WireMock Docker, which is basically a WireMock standalone service. It just bundles Java implementation and provisions it as a separate service. Yeah, I usually focus these talks more for WireMock experts. So the question to you, do you want to see examples of configurations, etc.?
Yes.
Okay, let's do it. And I will show it actually in test containers just to save everyone's time. Yeah, you know, just a few days on Twitter, there was a meme about product managers doing comparison matrix between things like Docker and Kubernetes, I believe. And he was saying that Docker is a whale, so a big plus. So this is a diagram like that, but still it provides you some insights. For me, WireMock and Testcontainers, they're quite good. So the key difference that impacts your decision is that server implementation is needed for yeah, it's a mistake. For test containers, server implementation is actually needed because you need something, you need business logic to run test containers. But for WireMock, it happens on the API levels. And for testing on the server side, it's actually quite opposite. So you don't have anything in WireMock. There is no server in principle. So if you want to improve coverage, if you want to co-test server and client, of course, WireMock isn't suitable for that by design. And one thing that is important that multi-platforms, so test containers now is more powerful in terms of supported platforms. So for example, for Rust and for Golang than WireMock, there is a lot of implementations, but they are not unified. There is no alignment between them. So using them is quite complicated. And these days I recommend basically using WireMock Java, maybe WireMock Python, WireMock.NET if you feel, if you need this particular implementation, but other implementations, they need to be aligned with what we have. So, yeah, I just need 5 minutes, I guess. Okay, so yeah, there is no silver bullet, and let's just define a common algorithm. So if you need a database or any other environment, of course, you go with test containers. So WireMock doesn't have context, doesn't have data. There is actually a lot of tweaks. For example, you can use WireMock with tools like Synthesized.io to inject big data sets. Synthesized is another open source tool, but it's more complicated. If you have a ready implementation, then test containers is feasible. If not, WireMock is your only solution. If your application cannot be containerized, WireMock is your only solution. And if you can easily trigger scenarios, then probably test containers is your solution. But if not, it could be WireMock. Long story short, your mileage varies, and you need to take a look at the particular use case. But I believe that actually we think, so I think that things are used together quite well. And actually what I did, one of the first items when I joined WireMock is creating a test containers model for WireMock that allows you to get benefits of both approaches by provisioning WireMock instances there. And this is what I will actually show to you. Yep. So I use IntelliJ IDEA, and I hope that everything works well today. I will just show you how one test looks in WireMock. It's a very simple implementation. And here, for example, yeah, let's take a look at the JUnit 5 test we looked at before. So basically, the interface will be more or less the same whether you use WireMock Java as is or whether you use WireMock test containers. It's just names of rules are different, but we aligned all the APIs by now. And here you basically say that you need WireMock server, you set up 2 mappings that you need. And for example, one of the mappings I also rely on external resource because I think it's handy. And here, if we go to these resources, we can just see how it looks like. So this is hello world JSON. You can see that it's super simple, but when we talk about dynamic behavior, about stateful behavior, then this file can go to thousands of lines, maybe. And then this is when you can depend on custom extensions to make it simple. And yeah, other files are pretty much like that. But here, for example, we take body for another file, which is also quite simple. It's just a little subset of features that WireMock actually has. I do not want to go into details here today. And yeah, this is our test. So in our test, which definitely requires Docker. So it will be probably the longest part of the demo. I'm starting Docker. But yeah. if we take a look at the test itself, so here I have a bunch of tests and all of them are quite simple. So we just demand what we need. Yeah, now it's starting. And here, for example, in some requests, we can also tinker with bits. For example, if you can pass headers, you can pass other metadata, which again can be processed by WireMock. So for example, if you use cookies, you can use WireMock. There is adaptation for that. If you want to submit forms, if you want to submit JSONs or XMLs, again, WireMock has a lot of custom matchers that can verify this content and extract ones. And things like that. So let's see. Okay, let's assume that it works. If no, this is why we rely on test containers to say also that our environment isn't ready. So let's see. So in principle, this part is quite simple. You can see that there is some other tests like extensions, because WireMock also has extension engine, so all the kinds of behaviors can be extended. For example, we have an extension for course authentication, which is needed sometimes. If you need to use SSL, HTTPS, it's out of the box. But for more complex things, you can have it. One popular question is whether you can actually mock Active Directory with WireMock. The answer is no, you cannot. And well, I'm not sure I would even recommend doing so these days. So here was our test. So in this test, yeah, it basically took 16 seconds just on the cold machine with empty cache, etc. So it provisioned the container, it ran the test, and it exposed everything. And it's not very interesting here because it was just provisioning all the things, providing a response, and sending hello world back. So we just verified that this test actually works. That's it. And yeah, what I wanted to show you is that these files, etc., this is how you do all the configurations. For advanced use cases of WireMock, which I'm not covering today, we actually invested quite a lot of time doing better documentation and extending things. So if you go to WireMock.org docs, here you can find a lot of examples for different use cases. So for example, if you want to know more about how the requests are handled, for example, templating, etc. You just go to these buttons and you can find a lot of samples, and including code samples and JSON samples. Later, we hope to have implementations for other languages, and you can find all the examples here. So there is actually quite a lot of documentation specifically on stubbing and verifying. So please be sure that WireMock isn't something you can implement in 5 minutes. Actually, there is a lot of work put by community there. By now, there are more than 300 contributors who committed to WireMock and who improved the things. So there is quite a lot of stuff. So what else I wanted to say? Actually, there is one frame case which I'm not describing today, but you can use WireMock as a proxy. So if you need to inject failures, etc., for a real service, it's something that you can do for both Docker Compose and test containers, and it actually provides a lot of value. You have stable service, you want to inject errors, you put WireMock. You want to reproduce complex cases, you put WireMock too. So same for proxying, etc. There is a lot of features you can do. And if you need advanced cases like chaos engineering, etc. So again, I'm not doing a demo today, but this is actually where cloud can be helpful, because for large-scale testing, for random testing, and you do chaos engineering only if you do stress testing these days, you can actually find a lot of solutions there. So just a few takes away. So yeah, API mocking and abstractions, they are a great solution for a lot of integration testing purposes. There is no silver bullet. So sometimes you have to choose WireMock. Sometimes you have to choose test containers. Sometimes you actually have freedom on how you approach the implementation. And I think that these tools actually work really well together. And this is something you should consider. So these days, I believe that containerized implementation of WireMock will be picking up. And Java implementation, it's super powerful. It has a lot of features, but yeah, once all the interfaces align, I think that it's something that will be just available to all the languages. And of course, we have a roadmap with a lot of things. So if you like contributing, if you want to participate in open source, this is actually a really good time to do that because, yeah, we are looking for more contributors. So if you have features, if you have extensions, just let me know, and I would be happy to discuss them. Okay, that's it. And I believe we still have a few minutes for questions. Yeah. Okay.
What's the level of support for things non-HTTP, like gRPC or other protocols?
Okay, so for that, we have a few implementations. So for GraphQL, there is implementation that is going on right now. There is a lot of discussions in the community, and if you need GraphQL, join us. For gRPC, there is actually a few of implementations already available. One of them is hosted in our repository, so you can take it. But it's a front-end proxy container that basically converts gRPC to REST API with some conditional rules. We want to have something more sophisticated with a lot of advantages as a part of Java, but now it's a standalone container. For other event protocols, I have a draft for Cloud Events implementation. If you like observability, maybe I will have some more implementations in the future. But in principle, if you want a converter, you can do it easily. If you want to have embedded implementation, there is extensions and things like GraphQL. At the moment, they're done purely as like WireMock extensions, and I think this is a viable approach for more protocols. Mm-hmm. Yeah. Yeah.
So sometimes it's hard to convince people to use integration testing with like mocks. They just say like, why not just mock it with a Java method or something like that. So can you give a few examples where you were using WireMock and you caught some issues or bugs, and it would not have been possible to do it with just.
Well, first of all, yeah. So the question is, what is the difference between WireMock that does full testing and basically modifying your application by frameworks like Mockita or PowerMock? So the answer is quite simple because firstly, when you use WireMock, you don't have to modify your application, so you don't make assumptions. And actually about networking, there is a lot of assumptions made in terms of request sequences, in terms of delays. So sometimes when you just abstract from the interface, especially when we talk about time-sensitive applications, mocking isn't enough. Plus, when you isolate big libraries like, let's say, Apache HTTP client, native implementations, and a lot of asynchronous stuff too, then yeah, again, you cannot be sure how it behaves in real. So in Jenkins, I WireMock for remoting testing. So all kinds of agent and Jenkins controller issues. We actually caught a lot of bugs when using WireMock for remoting for protocol. This is what is used in Jenkins by default these days. Okay, I guess one more. And,
For integration test, there is an approach to sometimes to go to the layer without third-party API. So catch changes in the API and some stuff, which is not exactly like WireMock approach to the mock.
well, you can use WireMock as a proxy. If you so the question is basically for integration tests, a lot of people go to external APIs and get response. And in WireMock, seemingly, you cannot do it. In fact, you can, because WireMock is a proxy. So you can basically, as I mentioned in the end, you can put it in front of existing service and basically send some requests to real service and mock some of the requests, actually even to do some comparisons. But when you rely on external service, then basically all your tests rely on this external service. So there is additional point of instability. But yes, if you need it for your integration tests, you can easily combine it with WireMock. And for example, what I normally do, I inject failures with WireMock because injecting failures, let's say, to GitHub, well, it got very easy these days when it basically fails every week. But before that, it was more complicated. So now I used WireMock, for example, for GitHub API testing when we were working on GitHub checks plugin for Jenkins. Yeah, it works quite well. Okay.
Thank you.
Okay. Thank you.
חמש דקות הפסקה, ואז נחזור.